Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arifbut.me. You can click the appropriate link under the lecture resource column to view it in NB Viewer and run it online in Binder. The other way is to download it from the course GitHub account Arif and all the notebooks for this course are housed in the public data science repository over here. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 3.2 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. My dear students, in the last session we started with NumPy, and before I move on and talk about different operations that we can perform on NumPy and its applications, I think it appropriate to have a brief comparison between the Python list, the Python built-in arrays, and the NumPy arrays. So it is important that we need to understand the differences between these three so that we should know when to use which data structure. Okay, so this is the learning agenda. This will be a short session. I will have a quick comparison between Python list, Python arrays, and NumPy arrays. And I will show you a memory consumption of Python list versus the NumPy array. Moreover, we will use the time it or maybe the time method to find out the time differences between different operations once they are performed on Python list as compared to NumPy arrays. Actually, I just want to prove that the NumPy arrays are very fast and very efficient, and they conserve memory as well as compared to the Python list. Okay, so let's start playing. So first of all, Python list. My dear students, let me read this out for you. We have already studied that Python list is actually a numerically ordered sequence of elements that can store elements of heterogeneous types. It is iterable, mutable, and allows duplicate elements. Well, we have seen that Python list is a built-in type in Python, and you can easily create it by comma separated values as shown over here, enclosed in square brackets. And moreover, you don't have to specify any type while you create a Python list, and the type is dynamically decided by the Python runtime environment. And Python list is by default one-dimensional, but you can see over here we can create further dimensions within a Python list, but even then it will be a 1D list storing another 1D list. And another important point to keep in mind that items are stored non-contiguously in memory in case of Python list. Let me move up to the diagram. Remember, this is the diagram that represents the memory representation, how the elements inside a Python list are stored, and of course they are non-contiguous. Okay. And of course it is very memory hungry, and operation on list are slower. However, the append operation of course takes big O of one time. Okay, so we have seen list quite a bit. So this was just a review. We have also seen the Python arrays. A simple Python array actually is a sequence of objects of similar data types. Over here we have similar data types. And this Python array module, you don't have to download and install it. It comes pre-packaged with Python. You just have to import it and you use the array constructor to create a Python array. However, you do have to mention the type code, and these are the list of the type code. We have seen this before as well in our initial sessions. And of course, it returns a new array of items. Let me show you some code. So over here we have imported the array module, and note the type specifier. We have mentioned signed integer I, and in this case this will take a minimum of 2 bytes. Each element will take 2 bytes, and over here the type is F. So this is F. It will take a minimum of 4 bytes. And of course we have seen that the Python arrays can dynamically grow and shrink as well, and this is not the case for the NumPy arrays. So let me run it. I hope this makes sense. One more point I just want to mention, that uh, over here we have integer type, but it is typecasted to float, the bigger type inside this list. Okay, as far as the NumPy arrays are concerned, we have seen it, an intro to it in the previous session. Uh, let's have a comparison of the NumPy arrays with the list and the Python arrays. Once again, NumPy array is a numerically ordered sequence of elements. It is stored contiguously in memory, and it stores elements of homogeneous types. But over here you see I have mentioned different types. It is iterable, mutable, non-growable and shrinkable, and it allows duplicate elements as well. Well, my dear students, remember NumPy arrays have fixed size while you create it, unlike Python list and arrays, which can grow dynamically. And if you try to change the size of a NumPy array, it will create a new array and delete the original one. And finally, the most important point is NumPy arrays are less memory hungry, and of course offer better performance than Python list. So if you see over here, I've created a NumPy array which has a float value, a boolean value, an integer value, but it has converted all of these to float 64. The false has been converted to 0 point, the true has been converted to 1 point, and this 9 also has been converted to 9 point. Okay, so that means NumPy array upcasts data of all elements to bigger data type in case of different types you have mentioned. Okay, so over here as well, you see I have mentioned a string over here. Let's create this array. It has once again not generated an error. Rather, it has converted all the elements to type string. You see, this 3.5 is a string. So this is the difference between the NumPy array and the Python arrays. And of course, you can mention the data type of your own. And over here, I have mentioned the data type. You will see it will be automatically typecasted to uint16, this false to 0, this 2.7 to 2, this 9.8 to 9. And over here, if you mention the data type of the element like this str, so they will be converted to string. So this is one important point that I just wanted to highlight as compared to the Python arrays and the NumPy arrays. Okay, let's talk about the memory consumption, a comparison between NumPy array and Python list. My dear students, over here I am creating a list of 1000 elements. I have imported the sys module because I want to use the get size of method of this module. So I've got the size of the element of this list, and I have multiplied it with the length to get the total size of this list. So over here I am just printing the size of each element of this list and the total size of the list. And similarly, I am doing the same for the NumPy array as well. So these two print statements will tell you how much memory cost is there for the list of 1000 elements, and for a list and for a NumPy array of 1000 elements. Great. So every element for Python list takes 48 bytes in memory. So for 1000 elements we have 48,000 bytes. On the contrary, as far as the NumPy array is concerned, it takes size as per the D type. So if I mention the D type as np dot uint8, so you see, So you can easily conserve memory whenever you are using NumPy array as compared to Python list. Okay, the next point is the speed of operations. Uh, my dear students, NumPy arrays are since stored in a contiguous memory location, so processes can access and manipulate data very effectively. And this behavior is of course called the locality of reference. If you see this piece of code in this cell, I have two arrays, my array 1, my array 2, having 6 elements each, and I am multiplying these two arrays to a third array. So element by element multiplication, simple. But in case of a list, you have to enter in a for loop to perform the same task. Let me do that as well. So great. Now let's see if we have a NumPy array of a million elements and we want to multiply such two NumPy arrays. What is the time complexity of that, and what is the time complexity for the same operation on list as well. So over here you see let me generate two arrays of 1 million elements, and let me use the time method of the time module to start the time, and let me perform this operation, multiply both these array elements element by element and place them in this array. And once again I'm calling the time method of the time module, and between the initial time and the finish time, if I find out the difference between these two times, I can easily compute, I can easily think of that this is roughly the time that this operation has taken. So over here I am subtracting that time. I hope this code makes sense. Let me run it. So it is taking about 0.0084 seconds. So let me repeat the same operation on a Python list. You see we have a list of same size, 1 million, and I am entering in a for loop to perform the operation this time for the list. And of course I am timing this piece of code before and after as well. And let me run this as well. So it has taken 0.2170 seconds. So what is the difference? So this has taken 0.008 second and this has taken 0.217 seconds, more than 200 times faster. So NumPy arrays, operation on NumPy arrays are far more faster than the Python list. And this is just one operation which I have shown you. Okay, so that is it. Right. Okay, my dear students, that is all. This was a short session. I just wanted to have a comparison between the Python list, NumPy array, and the Python built-in arrays, so that you should have a fair idea that in what situation you should use which data structure. So that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. And I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.